Hello students. In our previous sessions, we have started this topic called as derivatives, and we have learned some very important concepts in those lectures. In this session, we are going to start with another very important concept of derivatives, and it is called as parametric function. Now students, parametric function is one of the most important concepts of derivatives. So make sure that you watch this entire video until its end. I welcome you all to this channel. My name is Pankaj Lade. Let's begin with the concept of parametric functions. Now, first of all, we'll need to understand what a parametric function is. So for that, we will need to know a concept of parameter. What a parameter is. Once we understand what a parameter is, we can go further to understand what a parametric function is. Now, to understand the parameter, I'm going to take the example of a standard circle. I hope you all remember what a standard circle is, isn't it? A standard circle is a circle whose center lies at the origin, isn't it? So I'm going to consider a standard circle. So let's take the x-axis, let's take the y-axis, and the circle is made in such a way that the center of this circle is coinciding with the origin, isn't it? So that's your center of the circle, and the same point is the origin. So x-axis and y-axis. Now let's say r is the radius of this circle. Let us call r is the radius of this circle. So I'm going to call this point as P. Now have you noticed where point P is? Point P is a point on the circle. Now for simplicity purpose, I have taken point P in the first quadrant. It can be taken in any quadrant. It can go into the second quadrant or the third quadrant or the fourth quadrant, does not matter. So it has to be in the first quadrant or the second or the third or the fourth quadrant. So that is not going to matter. So for simplicity purpose, I have taken point P in the first quadrant. Now let us say the coordinates of point P are taken as x comma y. Now do you know that these coordinates are called as the rectangular coordinates? We call them as the rectangular coordinates. Now people understand this segment OP, which is the radius of the circle, let us say the length of this segment is taken as r, because r is the radius of the circle. Further, the angle that is made by this segment OP with the positive direction of x-axis, that's your positive direction of x-axis, and that too in the anti-clockwise direction. Now these things are very important that I am telling over here. I have said that the angle made by segment OP with the positive direction of x-axis in the anti-clockwise direction. So this angle, I am taking it as theta. Now if I draw a perpendicular from point P onto the x-axis, let's call it as M. So PM will be called as the y coordinate. PM is the y coordinate and OM is the x coordinate, isn't it? So PM is the y coordinate of the point P, and OM is same as this length Pn, which is the x coordinate. Getting or not? So I'm going to get the values of x and y. So if I try to get the values of x and y, I'm going to make use of trigonometry. Let's take the help of trigonometry. So in triangle, or better I should say in right angled triangle. So there is a right angled triangle. Look at this. This is the right angled triangle that I'm focusing on. Triangle OMP is the name of the triangle. So in right angled triangle OMP, if I ask you to write cos theta, now do you understand that theta is a variable, isn't it? Theta is a variable. Theta can keep on varying from 0 degree to 360 degree, or I can say it is 0 radians to, you can say, 2 pi radians. So theta is a variable, isn't it? It can take any value lying between 0 degrees to 360 degrees. Can you tell about r? What could be r? Is r a constant or a variable? So you need to think about this point. Is r a constant or a variable? So you can understand, once I have fixed my circle, the radius is going to be a constant. So r is a constant for me. Are you getting this point? Radius is a constant because I have already fixed the radius of the circle. It is not going to change in this particular matter over here, isn't it? So it's not going to change, hence radius becomes constant, but the value of theta can keep on changing. Right from this point, let us call it as A. So right from OA, if I keep on rotating this radius, it will keep on changing its value, and the value will vary from 0 degrees to 360 degrees, or if I want to call it in radians, I'll call it as 0 radians to 2 pi radians. That means theta is your variable. So now if I ask you to get cos theta, so we know cos theta by trigonometry is given by adjacent upon hypotenuse. So people, if I ask you what is adjacent over here in this triangle, is it OM, the x, isn't it? It is adjacent, so I write x here, and the hypotenuse, which is the radius, I write r here. So x comes out to be r cos theta. So x is r cos theta, and likewise if I write sin theta, it is opposite upon hypotenuse, which is y upon r. Therefore y becomes equal to r sin theta. Now try and understand this. X and y are the coordinates of the point P. As the point P keeps on traveling along the circle, the coordinates will keep on changing. That means I can say x and y, they are both variables. Isn't it? X and y, both of them are variables, because as the point P keeps on changing its position, the value, the coordinates will keep on also changing. So x and y are variables. And do you observe now, I have formed a relation of x and y, both variables, with a common variable which is theta, isn't it? X and y are now directly related. They are both depending on a single variable which is theta, because theta is also a variable. You know that theta can keep on changing its values from 0 degrees to 360 degrees, or we can say 2 pi radians, isn't it? So theta is a variable and r was a constant, because r is fixed at this moment. Some value has been already allotted or awarded to r, so r is not going to change. Who is going to change? The value of theta is going to change. So the two variables x and y now depend on the variable theta. So theta is called as a parameter. Theta is called as a parameter, and people, this equations x equal to r cos theta and y is equal to r sin theta, these equations will be called as parametric equations. We call them as parametric equations of a standard circle, isn't it? The example that is under consideration over here was a standard circle. So this standard circle has now what equation? The Cartesian equation was given as x square plus y square is equal to r square. That's the Cartesian equation of the circle, isn't it? So now the same circle can also be represented with a different set of equation, and that equation is given by x equal to r cos theta and y is equal to r sin theta, where theta is a parameter. It's a variable, isn't it? So two variables x and y depend on a single variable theta. So now I guess the idea of parameter is very clear to you. So a parameter is basically a variable. A parameter is basically a variable on which two or more variables can depend. Two or more, I said, isn't it? In this case, we have to only focus on two variables, because we are going to study entire calculus only in 2 dimensions. So therefore, we are going to restrict ourselves only up to two variables x and y. So two variables x and y, when they depend on a single variable, that single variable is called as a parameter. The equations are called as parametric equations. Now, to understand this concept in more detail, let's take one more example of a parabola. So if you remember, a standard parabola of the first type is given by y square is equal to 4x. Now I'm going to tell you one more important concept over here. Did you notice the two equations, x equal to r cos theta and y is equal to r sin theta? These parametric equations, when you substitute in your original equation, the Cartesian equation, the left hand side of the equation, the equation will definitely get satisfied. You want to check? Let's check. X equal to r cos theta, y equal to r sin theta. Take these values, put up over here. So x is r cos theta, you put r cos theta, do the square of it. Then you put y as r sin theta, do the square of it. So I'm solving the left hand side. So that's r square cos square theta, that's r square sin square theta. You can take out r square common. Cos square plus sin square is 1, isn't it? So what is left is r square on the left side, and the right hand side is already r square. That means the parametric equations are definitely satisfying the Cartesian equation. So over here I have written the equation as y square is equal to 4ax, isn't it? That's the Cartesian equation of a standard parabola. I am going to take the parametric equations. Now this is obviously learned in 11th standard conic section. So now we are not going to go into the detailed explanation how the equations arrived, isn't it? So here I have explained how the equations arrived. So we are not going to spend much time on getting the parametric equations, or here I am going to write them directly. So observe here. So if I write x is equal to at square and y is equal to 2at. So over here a is a constant term and t is a variable. It belongs to any real number. You can take any real number that you want. It can be positive, negative or 0 also. So t is some real number that is taken over here. It's a variable, and x and y are written as at square and 2at. Let's see what happens if I substitute in the LHS. So LHS here is y square. So what's the value of y? It is 2at. So if I write 2at and I do the square of it, the answer comes 4a square t square, isn't it? That's the left hand side I have solved. Let's solve the right hand side. So RHS is going to be 4ax. So let's write 4ax over here. So I get here 4a into x is what? The value of x is at square. So I write at square. That gives me 4a square t square. So now if you observe the LHS and the RHS, both of them are giving me the same value, isn't it? That means these two equations which are written are satisfying my Cartesian equation. So these equations will be called as parametric equations. So they are the parametric equations of a parabola of the standard type and of the first type. And what's the parameter over here? T is your parameter, isn't it? T becomes your parameter over here. So students, that's the concept of what a parameter is. So basically a parameter is nothing but what? It is a simple variable, isn't it? Usually it is a real number which will keep on changing. The value is not fixed, it is not constant. So a parameter is basically a variable, and two or more variables depend on that one single variable. The equations will be called as parametric equations, and the variable, the single variable, over here it is t, over here it was theta, it is called as a parameter. So I hope now the concept of what a parameter is very clear in your mind, isn't it? What a parameter is and what parametric equations are. Now what we will see is the parametric differentiation. So let's move ahead with the next concept of parametric differentiation. So students, now let us try and understand how to differentiate a parametric function. Now obviously we are going to write a theorem statement. We have separate videos on theorems. The derivations that we are going to see will be discussed in a separate video. So here we are just going to understand how to differentiate a parametric function. So now observe carefully. I'm going to write the statement over here. Observe carefully what the statement is. Let us say if x is some function of t and y is some other function of t. Now x and y are both some variables and they are depending on the variable t. Are you getting it? X and y are some variables and they are both depending on the variable t. So what could t be called as? Now you have to know this, isn't it? You must definitely have understood that t is a parameter and x equal to some function of t and y equal to some other function of t. These will be called as the parametric equations. So they are the parametric equations and t is the parameter. Now students, I have the parametric equations, I have the parameter. The other important thing that should be considered over here is that these two equations should be differentiable equations. They have to be differentiated completely. I should be able to get the derivatives of both the functions completely. So x equal to some function of t, y equal to some other function of t, where t is a parameter, are differentiable functions. They are differentiable functions where t is a parameter, isn't it? So now if I want to get dy by dx, so I want to get the derivative of the function y with respect to the function x, so I am differentiating y with respect to x, dy by dx. Now try and understand, x and y, they are not related to each other directly, they are related to each other through the parameter t. We have seen the example of a circle, isn't it? The parametric equations were x equal to r cos theta and y is equal to r sin theta, and these both equations was satisfying the basic equation of circle, which was x square plus y square equal to r square. So x and y are both related to each other through the variable theta. Here also x and y are both related to each other through the parameter or the variable t. So now if I want to get dy by dx, I will be getting the formula something like this. Now y is actually a function of what? It is a function of t, so I should differentiate it with respect to t. So I'll be getting dy upon dt, and similarly x is also a function of t, so I will be getting dx upon dt. Now remember that dy and dt are not two separate terms. This is the most important concept you have to keep in your mind, that dy upon dt, dy and dt is not a ratio. It is basically d by dt of y. Likewise dx upon dt is basically d by dt of x. So do not be in an impression that I have divided the numerator and denominator by dt, isn't it? So that concept is absolutely wrong. Your mind should not think like that, that dt and dt can be cancelled from here. So dy by dt, dx by dt, these are derivatives of y and x with respect to t. So this is how we get the parametric differentiation. Are you getting it? So let's take a simple example. So if x is r cos theta and y is r sin theta, so if I want to get what is dy by dx, it will be dy upon, so what's the parameter in this case? We know that theta is a parameter, so it becomes dy by d theta. Whatever the parameter is, you should be using the parameter, you should be differentiating both the functions with respect to their parameter. So dy by d theta upon dx by d theta. Let's very quickly get the derivative. So dy by d theta means you want to differentiate y with respect to what? Theta. So let's differentiate y with respect to theta. So that's d by d theta of, what's y here? It's r sin theta whole divided by d by d theta of, what's the value of x that we have? It is r cos theta. So let's write here r cos theta. Now do we already know that r is a constant? So from the derivatives the constant will go outside, so I will be writing here r is a constant. So let's write over here, so So in the numerator r is a constant, what is left? D by d theta of sine theta, and you all know what is derivative of sine theta. It is cos theta, isn't it? Please watch my previous videos on derivatives, all the concepts and the formulas. Please keep on following this channel. Now derivative of r cos theta, again r is a constant, goes outside. Derivative of cos theta is minus sine theta. Students, I hope you remember all the formulas. Make sure that you are watching all of my videos so that you understand this concept more better. So r and r gets cancelled and you can write the answer as minus of cot theta. So dy by dx came minus cot theta. So this is how parametric differentiation goes around. In this video we have understood what is a parametric function, we have understood what a parameter is, we have seen how to differentiate parametric equations. We have taken a very simple example to understand how the formula works. So this is where, students, I'm going to end my video. In this video we have only understood the concept of parametric differentiation. In my next video we will be looking into some critical examples of parametric differentiation. So students, keep watching the videos, follow the channel, and I will definitely make sure that you gain maximum out of these videos. Thank you all for watching this video. Thank you so much.